This is a video about using the Brunsviga Dupla you see here as a difference engine. What is a difference engine and why do you need one? Well, imagine you have a function like this quadratic equation at the top here, which you would like to calculate for a set of values of x in order to make a table. It would be a lot of work to do this by hand or even to do it by machine using the regular methods of filling out x and then calculating y. So what you can do is using the difference method, which means you calculate three values, the first three values for y, for x values of 0, 1 and 2, and then you calculate the difference between these two numbers, which is this 11,702 and this difference, which is 21,929. Since we have a second order function, you can also calculate the difference between these two numbers and we will find 10,227. We know, because it's a second order function, that if we would keep doing this, calculating values for y, calculating first and second differences, that the second difference would be constant. So this is what a difference engine is based on. Depending on the number of orders in your machine, you can also do third order, fourth order, fifth order polynomials. But in this case, we will use the Brunsviga Dupla as a two-stage difference engine to project a second order function without having to do hard or difficult calculations. The way to do this is to set the first number, 34,726, into the machine first. So we set 34,726 into the machine. We will leave the second result register engaged. So we will simply turn this into the machine. The next thing we do is we clear the bottom result register over here, and we set the first difference, this number here, 11,702, into the machine. 11,702. We disengage the second register and we crank this first difference. Oh no, sorry, we don't disengage the second register. We want to add the first difference to this number, of course. So we do that and we find 46,428. And we have the first difference over here. Now we disengage the second register and we put the constant second difference in the setting register. We add this to register number 1. The next thing is we clear the setting register. We transfer the register number 1 into the setting register. We engage register number 2 and we add this number to both registers. So we projected actually value number 3, 68,357 or 58, the half is missing, but alright, we're approximating. And now the first difference, the second first difference is here. So that means we can now clear the setting register, disengage the second register, and again put the constant second difference in the levers, crank it in. We now have the third first difference, which we didn't calculate, mind you, but it is now here. So we will now bring it back up to the setting register. There we go. We will engage the second register. crank it in, and we now have our next value, 100,513. We will keep doing this, clearing 10227, disengage the second register, crank it in, bring it back up, engage the second register. That's our next value, 142896. Clear, disengage, 10227, crank it in, clear, bring it back, engage, next value 195506, disengage, clear, 10227, crank it in, bring it back, engage, crank it in, 258343, disengage, clear, there we go. Three one 407. What we've also done before we calculate the last value is we can click this little button, which disallows register number 2 to be cleared, so we don't accidentally clear it, because that would of course be a disaster. 0227. So we're now going to add this here. Then we bring it back, engage. We'll do one more, which is 414698. And so what we're currently doing is simply calculating a table with the results for the function, the quadratic function, with a very small number of operations in order to get there. And the reason we can do that is because the Brunsviga Dupla has two result registers. So we can keep the total in one of them, and we can use the other one to alternate between first differences by adding the second difference to the first difference, and the back transfer from this register to the setting pins allows also to always add the first differences to register number 2. So that is actually what a difference engine is.